So the first 421 that I'm going to get 1 month from now, as of now, is worth only 420. Obviously, these things are going to go down. Come on. The last 420 that I'm going to get 30 years from now at these interest rates is worth 170, 160, right? Now, but I get the first 420 in 1 month, the last 170 in 360 months. So my call duration is simple. You're going to take the sum product, as the name suggests, it sums the products of two things, the period with the present values, but I need to divide that by the sum of the present values. Oops. So this says, this is in months, because periods are in months. I could actually, let me see, divide the whole thing by 12. Now this is in years. So even though it's going to take me 30 years to collect all the money, on average, I'm getting my money back in about 13 years. One thing you can show for a zero coupon bond, percentage change in value of a zero coupon bond as a result of interest rate increase of delta y is approximately Macaulay duration divided by 1 plus yield over frequency. Okay. In fact, we call this sometimes modified duration. Sorry. Or sometimes it's called financial duration. Of course, times delta y. Here's what that means. If, I mean, this APR right now I'm using for discount, so let me make these payments fixed. I mean, current value right now, sum of the present values, right? If we calculated the payment right, it should be 1,000 anyway. All right. Let's see what's going to happen to the value of this mortgage if I increase the discount rate, the APR, at 4%. Because if overall interest rate, mortgage rates run up, if I want to unload this mortgage off of my balance sheet, I have to sell it at 4% instead of 3. I'm going to tell you that that value is going to roughly go down by 12%. I know that from the Macaulay duration number. What do you know? It went down to 88,000 something. Okay, so it's a nice little measure of uh, interest rate risk. It's called financial duration. With bonds, basically, we're going to calculate. Same thing applies. Remember, a bond is a collection of zero coupon streams, right? So we do a weighted average of them, which means modified duration or financial duration of a bond is going to equal to its Macaulay duration divided by 1 plus yield over frequency times expected change in interest rate. All right. That's why then bond value goes down quite a bit. In fact, we could even estimate it numerically. Suppose I want to estimate the financial duration of any cash flow stream. I have a setup that I can calculate the value. So let's start with a 3 right now. I don't have to, but I'm just starting there. Current value is 1,000, so I'm going to copy and paste it here, the value. And I'm going to increase the yield to 3.01. Okay. And take the new value divided by the old value minus 1. And let's make that into a percentage. Basically, 1 basis point increase in the yield to maturity of this bond decrease the value of the bond by about 20 basis points. Sometimes we actually multiply this whole thing by 10,000. And make it into regular numbers. That's actually the financial duration or the modified duration of the bond. It's an estimate of that. The relationship between the yield and the bond value is not linear. So that relationship is curved. That's why we can estimate these only locally. Ideally, we would use the concept of derivative, but since you guys are assumed not to have seen calculus, we can't do that. I basically did a simple numerical derivative for you. Not that it matters. This means, roughly speaking, it takes you about 19 and a half years to get your money back from this bond, all right? Or 1 basis point increase in yields decreases the value by about 20 basis points. Sometimes you multiply that by the original price. That's actually sometimes known as value of 1 basis point. So if this was originally a par bond, 1 basis point is worth $19.50 loss. Of course, approximately speaking, if you go to 310,